Hello once again, students. I wanted to continue our talk in Chapter 12, and I wish I was there to do it in person, but circumstances dictate if I'm going to teach you at all, it's got to be remotely. So anyway, we were doing solving equations in groups in previous chapters. We can solve inequalities much the same way, and I introduced that to you on a previous quiz, which we had varying degrees of success, which incidentally, over these last couple of days of this week, you should have the opportunity to retake that quiz in cold time, but you have to arrange for that with the sub. So where was I here? So yeah, right. So we have an inequality such as x minus 3 is less than negative 15. The solution set is going to also be some inequality. In this case, it'll be something like, x is, or well, in this case, they did t here, but that was fine. Why did they say t is an integer satisfying? I don't know, just stick with x, but I didn't write the problem. Add 3 to both sides, though, because we take advantage of monotonicity, and, this inequality is still going to hold. We'll have t is less than negative 12. When you're going to graph that on the number lines provided, be careful. When we're graphing, x is less than negative 12, we don't actually graph this. Leave that one empty, and then you graph everything else. Because again, this was just an integer number line. Now, if it was a rational number line, then I'd have the ability to, circle that, start there and then shade, right? We've done that before. Anyway, so let's move on to another example here. And this is one where, I've taught this to you before. We have negative 35 minus t is less than negative 29. Obviously, we can add 35 to both sides, and we get negative t is less than 6. And remember what we've said about these ordered group properties that you should have been learning about here. That is, when we take the opposite on both sides, we wind up changing the order. See, and now they show it a different way. They say, hey, this is true if and only if we kind of swap their places, which of course means t is greater than negative 6. So when I have negative t is less than 6, I've got t is greater than negative 6. And so now, of course, because this one it said, solve it on Q, fine. I have an open circle on the negative 6, and the shading is off to the right there. Okay, cool. So exercise 63. We can work through a couple of these if you like. So on this one here, let's see, we've got negative 13 minus x on the right, negative 3 on the left. Okay, so one way to do this, by the way, is I could add x to both sides. What if I did that? See, that would make this go poof, right? And now I've got x plus negative 3 is less than negative 13, which is real easy to solve if I just simply add 3 to both sides, like so. And I've got x is less than negative 10, and it's over z, so my answers start at negative 11 and go on down all the way to negative 15, and then I put that little bent arrow diagram on there, okay? So on B, you've got 15 is greater than negative 9 minus x, okay. If I added 9 to each side of this, that would get me 24 is greater than negative x, which again, using the properties we talked about before, ordered group property 4, I would have x is greater than the opposite of 24, negative 24. See? So, and of course, when you're going to do that, now obviously the way this is kind of set up here, I need to change my starting point on my graph here, okay? So if you say, hey, started at negative 24, well, don't actually bubble that one in. You'll bubble in negative 23, negative 22, and so on down the line. Because again, remember, this is over the set of integers. Understand? Wonderful. All right, move on to another example. This is one of the exercises I took their instructions and such in the way that it has this here. You have to enter standard names of rational numbers. I just copied that, but I made my own example, as you can pretty clearly see. So let's see what this looks like. Let's see what we've entered in here. 5 minus x is less than 1/2. Fine. I'll add x to both sides. Make that go poof. And now I can take off, now that I got 5 is less than 1/2 plus x, I can turn this around and say x plus 1/2 is greater than 5. That's valid. And if I subtract a half off both sides, I get x is greater than 4.5, or 9/2. We'll put 9/2 here because it does say enter standard names of rational numbers. So for this, I'm going to put in an endpoint at 9/2, and I'm not going to put in a second endpoint. So on this, in this case, we're going to say no, you won't. You won't need it. And then when you click go, when you click that button, when you click go, now it's going to generate a nice little number line here for you to start filling in. So you've got the 9/2 right there. Here's 5, here's 4, here's 6, and so forth. You'll have an open circle at 9/2 and shade off to the right, and on wherever that last number is, it'll offer you the opportunity to put in a bent arrow, and that's exactly what you'll do. What do you think? Let's try another one. So if I had negative 2/3 x minus 4 is less than negative 4. All right, as I look at this, I know that if I take this, that's negative 2/3. If I take positive 2/3, I'm just going to change up the color here to contrast with the one above it. If I add 2/3 to both sides of this, fine, that'll make that go poof. So now I've got negative x is less than, and now I got negative 4 plus 2/3. That's going to be negative 10/3. And so therefore, I know that 10/3 is less than x by order group property 4. So I can write x is greater than 10/3, like so. So I put an endpoint at 10/3, click on the go button, and that should create a nice little number line for me here. And if I had 2, 3, 4, 5, I'll have something at, let's see, 10/3 is right about there. So call that 10/3, and the shading will be off to the right, like so, with the bent arrow, like so. All right. All right. So let's move on to next section here. Next section talks about how multiplicative monotonicity has different rules than addition had. In fact, I have all these different cases to explore as part of our exercises here. So one is where basically both values are positive, one where one's negative and one's positive, and one where they're both negative. And thus, what's the value? What value of C is going to change each of these. So there's a ton of examples. As you can see, it's actually, that's like 7 different instances there with respect to what C is, times 3. That's 21 different cases we're going to explore here. So, but we'll take them in turn. It's fine. I think you'll understand it just fine. So again, A and B are both positive numbers. If I say C is greater than 2, so try out C is 2, fine. Okay, fine. A times 2, B times 2. Inequality still holds. A times C is still less than B times C. If C equals 1, cool. The inequality holds. I still have A is less than B. Pretty obviously, when A times C is less than B times C. When it's a fraction, so like for instance, they say for the sake of choosing some example, we'll choose 1/3. So if I do A times 1/3 and then B times 1/3, it gets even smaller. But look, when it's all said and done, A times C and B times C are still in the same order that A and B were. Okay. Now I want you to talk with your classmates about how you would do exercise 66 in light of what I just told you, okay? All right, so you'll go do that, and when you come back, we'll continue. Okay, you're back. So when we look at cases 1D, 2D, 3D, we realize those are the ones where it's multiplying by 0, right? A times 0 is equal to B times 0 is 0. So we're not going to have multiplication by 0 preserving, that kind of order. Case 1E, of course, where we're choosing some negative fraction. See if the order is preserved. Okay, so here's A, here's B. And now when I multiply by, when they do that negative 1/2, as you can see, things got flipped, didn't they? So order's been reversed. Same thing happens with and A and B are both positive numbers here. If I multiply by some negative 1, again, B times C is less than A times C. And yet again, if I chose a deeper negative number, or small, I say smaller, but it's just further to the left of the number line. Again, A times C and B times C, the order has changed from where it was. Okay, now look at exercise 67 and talk with your partner about that. Got it? And when you're all said and done, hopefully you will see that these properties are going to apply on ordered rational systems like this. Okay, so multiplicative monotonicity basically is only going to hold if I'm multiplying by positive elements. Okay, so that's going to be this rule right here, this property. Multiplicative monotonicity holds if A relates to B and C is some element of the positive elements of S. Then A times C will relate to B times C. Okay, and again, definition of linearly ordered ring is as follows, which now, because since we had linearly ordered groups on addition and multiplication, it kind of follows that it's going to be a ring, doesn't it? So yeah, here's the definition of a ring, which again just easily follows from the fact that I already had addition as being a group, multiplication. I haven't even had multiplication show that that's a group, an abelian group itself. It doesn't matter. Right now I'm just trying to define a ring, and remember, for a ring I only need that that I have some neutral element and there's associativity and commutativity. Anyway, folks, I say this is mislabeled. This really should say exercises all the way up from up through. We are going up through 69. You should have to this point been up through let's see, 50. Yeah, no, I guess this is right. 61 through 69. Checking my notes here. Anyway. Hopefully the week is going well for you even without me. Hopefully you're getting something from these videos. Click that like button and be sure to subscribe to my channel and check out my links for merch. Just kidding. I don't really have merch. All right, but thank you for listening anyway. Have a great rest of your day. See you soon. Bye.